All right, hey everyone, welcome back to another week of hobby kernel development. This is week 27, and we're back at it again. This time we're going to keep moving on with exercise 2, which has been taking me a very long time because I was debugging some bugs in the last couple weeks of doing this, but I'm pretty hopeful this time that we can make I'm hopeful we can maybe finish these two functions today. So I'm just gonna quickly check in on the stream as usual, make sure the chat is working. Right. So last time we were working on the ELF loader and debugging triple faults within the ELF loader. That's where we left off. And yeah, as of right now, we have, to my knowledge, a fairly working ELF loader. Also, I'm trying a dark theme today for the first time ever on stream. So if I make a lot of mistakes, I'm gonna blame it entirely on the dark theme. But yeah, no, I've been using a light theme, but I'm open-minded and I'm willing to try out things to see how they work. Yeah, but oh, hey Uwan, from Pakistan, right on. Thanks for coming back. So last time we were debugging the ELF loader, and it was rebooting the machine in the process of loading the ELF binary. And I fixed the bug, and now we successfully reach this panic 333. And we can see that when I run the kernel, we hit the panic 333. And this is a good sign. This means that the main loop that loads the ELF segments into memory does not have triple faults anymore. What I want to do now is just move this panic all the way to the bottom of the function, and I'm pretty sure this is going to work, but it's been a bit, okay, yeah, so that worked. So that is good. All right. So there's this to do there, something with the program's entry point. I have that to do because it said something about that in a comment here. But I don't actually know what that thing is. You must do something with the program's entry point to make sure that the environment starts executing there. I mean, I think it's something like, something about the EIP or like the instruction pointer, like we need to initialize the trap frame or something like that, and set something within the trap frame to point at the correct EIP, but I don't actually really know much about that stuff, so maybe I'll learn about it today. Yeah, hello to everyone who is joining. Yeah, so what I will just quickly do is kind of take a look at my working tree because I didn't have a chance to clean it up. So I have my ELF loader here. Hey, digitalized. Yeah, let's check out. Oh man, I guess I need to change my fork, this thing to a dark theme too. I don't know how to do that though. Too bad. Yeah, let's see some comments on the dark theme. Hope you're doing well, digitalized. Hope you're having a nice Sunday. So So I'm kind of ready to make an like initial work in progress commit. So I have my tests. Yeah, so I could actually continue with that a bit. So I have these unit tests I was working on. That's in the check load icode function. And what I can do is I can finish up the unit test, basically. Because right now it's only testing one thing. So basically, I call the function load icode, which is my production code, and I pass it in a binary. And then the idea was to do some checks to make sure it did the right thing, which is what, yeah, lazy morning, we're going to do programming out of habit. Nice. Sounds good. Let me finish that. So we're going to hop back over to my unit tests. So, okay, so first of all, I need to actually, let me get rid of this panic. And if I'm understanding this correctly, I should now see a panic 88898. And I do this weird thing with these panic with these like random numbers just because they're like kind of easy to type, and I don't really feel like writing out specific panic messages for these little debugging things. So great, so now we're panicking here, and I can go back and kind of write my tests. So what tests do I want to write? Okay, I have too many tabs open. I'll also start my palm tree timer. Let me just uncomment these things. Hey Wizard, are you shocked at something? Yeah, let me see. I'm just uncommenting all of these other lines that I originally had, but okay, the PTE, so this, I think this all needs to, oh, wait a sec, no, I think yeah, so I wrote this check VA function, which can be reused. And what it does, you give it a page directory and you give it a virtual address. It queries that virtual address and looks up a bunch of stuff. It looks up to see if there's a physical frame associated with it, and it also tries to get the page table entry associated with it, and then we assert a ton of stuff. We assert that there is a physical frame, we assert that there is a page table entry, we assert that the page table entry is present, we get the page directory entry, we assert that it is present, and those are the main things. And then I think I was even kind of asserting that this is writable. I had a bug though, where I used an or. So the idea was that I can just do only these, I think. Let me just run this. I wasn't paying attention. Not paying 333. Okay, let me. Okay, wait, what? N.C. Oh, wait, how did this, it's back, okay. Okay, good, so now I just move this down. And it works. So it looks like my unit tests are working. So I'm gonna get rid of this, I'm gonna get rid of this. I'm gonna get rid of even this. So now it should say panic at check load icode. And it totally said that. So that's great. So now my unit test is kind of working. This is a bit of a, kind of a open question for me. Do I test if it's writable? So far, I think I kind of am not remembering this part of the code super well. I think we're actually making everything I think we're making everything writable that load icode loads or something like that. It was in the region alloc function, which I will look up. So region alloc is the helper function that is used by load icode to actually do the memory allocation. And in particular, it always passes the PTEW bit, meaning the memory it allocates is always writable, which I'm not sure it's correct, but I'm doing that because of this comment. It feels a little bit odd to me to always do this assertion, so I'll just add a Boolean parameter, which I think is not really good form. I don't love Boolean parameters, but I will just add one for the moment. And insert something like this. I want to assert, if we're doing the writable checks, we want to assert that both page table entry and the page directory entry are writable. And now I need to go update all these callers to have true. Does this work? Oh, cool. I'm trying to get better at my Vim. Oh no. Okay. Press the period key to like redo the last, I think, edit operation, but let me do that one more time just for fun. So true, and then I go here and press period, and period again. Okay. So let's run it again. And it still works, good. So that's looking pretty good. So now I just need to see. Hey Shovik, hello, welcome. Yeah, I had this stuff with poisoning the allocation, which is kind of a debug feature. Okay, I think I have a few things. So here, I think that was actually kind of a bug fix. I was not checking the return code of page insert, which I should have been doing. So that is a conceptually separate change, so it belongs in a separate commit. Check. Check. Okay. Check, what is it? Check page insert for errors. Check return code for page insert. Okay. What do I work on in my job? I work on musical instruments, actually, for electronic music. But I don't do operating systems programming for them. So then I did this thing where I changed the return type to an int, because why? I wanted to like, I wanted to return the actual full amount of memory that region alloc returned, because it internally, like, you give it a virtual address and you give it some like size, but then internally it's going to align and kind of like round both of those things to the nearest page size. So, so the amount of space it gives the client is possibly different from the amount of space that the client asks for. It might be bigger, basically. But the thing is, the client of this function is also responsible at least in our current implementation and design, for actually zeroing out memory. And so the client needs to actually know the full capacity. And so there are like two obvious options for dealing with this. The first one is to make the caller just kind of redo the rounding computation. But that like is error prone and copy and pastes code and stuff. So the alternative option I went with is to make region alloc return information to the caller such that the caller doesn't need to recompute this rounding thing. And that's what I did over here. So return size of full memory allocation from region alloc. Yeah, I always find commit messages a bit hard to write. So what I usually do is I kind of write a quick one, and then I usually go back and rewrite them after I'm done with the branch or whatever, before I'm ready to submit for a code review. Now this thing, which was like a debug feature, so I don't quite know what to do with that yet, but I can keep cleaning up all of this stuff. I don't want any of those lines. I don't want. That's kind of another tricky thing. It's like, it is possible that I might actually want these debug prints in the future. So I don't know if, and it's kind of cumbersome to add them back, so I kind of want to keep them in. But there's like some clear, obvious stuff that I don't do. This is relevant. Okay, I'm doing this now. Don't need that. Don't need that. Yeah, I'm a big fan of this kind of sculpting approach to Git, where you just kind of like, it's almost like you're literally sculpting a sculpture. You just kind of like sculpt away all the diff lines and whatever that you don't want. Don't think I need any of these. So now so it's back to the kernel, question mark, question mark. Yes, definitely. Yeah, there was like, is there a better way to do this? Like, in all cases, I want to switch back to the kernel. But then I want to return a different code. And I was trying to avoid like mutating a variable. But maybe that's actually more correct than like copy and pasting this like one line of code. So what would it look like? To avoid copy and pasting, I would do like return. Do I already have a ret variable? Is what return ret. So int ret equals 0, and then what fail is what, like ret equals -1. Go to ret. I don't know. This is just not worth it. Yeah, no, I'm just not gonna even try. I think I'm just gonna keep it like this. We just need to hopefully remember that we always need to set that. Yeah, you know what? Yeah, no, I'm just gonna do this. I'm just gonna make a ret, do it the old-fashioned way, ret equals 0, and then before go to fail, or maybe even ret equals 1, go to finish maybe. And now it's just finish, turn ret. And now we just do this. Oops. Yeah, that's probably better. Yeah. Maybe I'll call it. I don't know if I can call this return. That'll probably conflict. Yeah. Does this work? Yes, I think it does. Okay. So this is looking pretty good. I'm gonna stage this. So I want to add an assert. Yeah, I wanted to clean this up a little bit. So it's gonna be like, I'm just gonna call it int memset size. Oops, didn't mean to do that. Yank inside argument. I'll maybe change that int to something else later, but whatever. And assert that memset size 0, right? So I'm doing this in response to this comment I made, which was about how it's dangerous, how it's maybe dangerous to do pointer arithmetic, which might be signed. I think in reality it's like a pointer diff t or something like that. Do I even have that type? I don't even know. Because these both are void pointers. But I don't think I have a pointer diff t. Like I'm not actually sure, yeah. Yeah, it's like, do I even have, I don't even have a, like, ag size t, ag define. I don't really know where my, I could have sworn, I was like, is define what I'm looking for? I could have sworn that, or yeah, types.h, what is types.h? Yeah, type def, that's what I was like, this is the type def, yeah. And so I don't actually have a type def for pointer diff t. Do I want one? I don't even know what it should be type def to, to be honest. Int pointer t. Yeah, but I think the key point there is that I can't just like use all these standard C types because I don't have a C standard library, straight up. Like I need to, like, I'm making it myself. So therefore I'm just gonna use an int. But anyway, the point was I have this comment saying it's dangerous to do pointer arithmetic, which might result in a signed int, or specifically might result in a negative int. And it's kind of dangerous to do that directly into the argument of memset, because memset receives it as an unsigned integer. And so if you accidentally pass in a negative number into memset, it's going to interpret that as like a massive number and like smash like all of your memory, basically, which you want to avoid. So I'm going to add an assertion here. And I will now try to be very smart and use vim to memset size. And now I'll jump to this place and replay that. And yeah, with the period thing, that was awesome. All right. So now maybe this goes all here. Yeah, I still have this thing with the printfs. Oops. Kimu. But this is still working. So I can get rid of this. All these prints. Print F, Vim, very smart. So what was this to do? Right now I have an assertion that the file size must be less than or equal to the mem size. And I have this comment to remind myself that maybe I shouldn't do this. Maybe I should return an error to the caller. But like in order to maybe more gracefully handle malformed ELF binaries, that's specifically, yeah, that's an option. I don't know how much I care about that. I don't know how much I really care about making this thing so resilient to like untrusted input, which might sound kind of stupid because typically when you write a kernel, you want to be like super untrusting of all inputs to avoid getting exploited or whatever. But the thing is, I have an assertion here, so I already have an assertion, so it's not like I'm just ignoring this edge case. It's more of like a stability thing, like how like gracefully I'm gonna yeah, 17 seconds break. I'll be right back and finish that thought. Yeah, it's like more just like a contract with the users of the system. On one hand, you might say, well, the kernel should be super graceful, and if you pass it a malformed binary, it should just like not die, basically. Or on the other hand, I could just say, don't pass malformed ELF binaries to the kernel if you don't want it to crash. And I kind of think that's the stance I want to take, just to keep things a bit simpler. Which is not really a trade-off you usually make in production software, but this isn't really production software. So I don't think I need this. I don't think I need this. I don't think I need this. I'm just to kind of keep it moving. I am going to just comment out. I don't know. These, yeah, I can add these back if I need to. Kind of, yeah, whatever. It's not really super. Well, I don't know. I might find myself debugging these things very quickly because I'm not fully confident that this is super solid production code yet. It's major to do. Oh, right. And here's the to do for the stack thing, which I think is right. Let's go back to here. So basically what I'm just doing is kind of like half cleaning up the ELF loader implementation. Just kind of just enough for like a WIP commit. I am, so I mean maybe, yeah, I can stage this, I can basically stage all of this, and I'll stage this, and I would just, whatever, I'll stage this one too. So this is just kind of like initial load, icode, initial ELF loader. Just to keep moving. And what do I do with this debug thing? This debug feature. I could just keep it in there all the time. Maybe I'll add a to-do saying maybe don't. So here's the thing where I like poison the allocation with hex 42s to make it clear what is uninitialized memory. to do. Don't always do this, make it configurable, something like that. But really the only reason to do that is for performance, and I don't really care about performance right now, because I would make a new kernel if I wanted to care about performance, I think, and just redo it from scratch. Gen alloc, or add poisoning to region alloc. Nice. Okay. We have our little panic. So that's good. And what other tests? Now, yeah, what other tests could I write for this function? Load I code. So you give it a binary and then it does a bunch of stuff. And I'm trying to test. So for this particular binary, so I'm checking, so basically these random numbers all just came from the ELF program header. So the command to check out an ELF, you use read ELF, that's like the tool you use, and you pass your ELF binary to it, and then you specifically want to go to the program header section, like program header part of the output, where you can see all the load headers, which are the pieces of data that basically advertise what parts of the ELF should go where in memory. And that's where I copied these numbers from, 200,000 and so on. I guess I should also add some to-dos about respecting some of these other things, like the flags and the align. Maybe I'll also do that. It's me respect the flags and alignment of program headers, question mark. Currently flags flaws, i.e. Permissions and alignment is ignored. I was waiting for you, Afnan. Yeah. What in the flashbang society? Yeah. It's Christmas. It is Christmas. Hope that oh, that's better. Yeah. I mean, I have to say I don't mind it that much, to be honest. I mean, it is daytime, you know. The world is kind of bright around me, but it's also not as bad as I thought, so I'll give you that. Yeah. Using the transparent background. No idea what you mean. All right. Oh, it just blends into my wallpaper. Funny. In VS Code, you mean? So yeah. So what else do I need to check here? Cool. Thanks. Oh yeah. By the way, Afnan, thanks for posting your project in the Discord. Yeah, pretty cool stuff. So now. I could do some more checks. I could also check that certain page, like, what if I wanted to check that a page is not allocated? Yeah, I don't really have I don't like immediately have a function to do that. Maybe I could make this return like a Boolean or something like that, and then assert Yeah, I don't know. It's kind of annoying. I kind of just want to move on forward to and not spend too much time writing tests. But yeah, are there any more basic tests? So I'm doing pretty much the most bare bones set of tests right now, that these 3 virtual addresses get mapped after that function is called. What? So I could test that the data is actually copied correctly. I could test that the mem setting happened, and I could test that a stack got allocated. How does that work again? It's at a fixed location, I guess. Use stack top minus page size. And so yeah, I guess I could do that. But wait a sec, this variable name is wrong. There's this top of the stack. Use stack top. There's the top of the user stack. And I subtract the page size to get the bottom of the stack. So stack, it's like more like stack bottom vAddr or something like that. Yeah, I'm going to quickly, or maybe it's just faster in fork. I'm just going to amend this. But that's not actually where I wanted to amend it to. I want to amend it into here. Yes. Okay. Hey, Jax. Have I worked with real-time operating systems? Not really, yeah. No, I wouldn't really say I have too much. Okay. So I could, yeah, so basically I could do something. I could also, where is this defined again? I could also do something like u stack top minus page size, right? Basically recreate the same thing. I just want to stack bottom. I just want to avoid copy and pasting code if I can. So I can make a new define for that. And then I can come here and be like, you stack bottom true. And I can try to run this. And that works. And then I'm going to make it fail by subtracting like 5 from it. And this should fail because I'm going to go below the stack page, which I'm pretty sure is not mapped, I hope. Assertion failed, P, good. So, great. So I have pretty much like an absolutely minimal set of tests. And I will just hello, right? fork as much. It's a bit faster if we can just do that. All right. So then I'll just amend it back. Right. Just this and I will just amend it into that commit. Okay. Good. So, wow, it's already 40 minutes. That's why I make no progress on this, because I spend like half the stream just cleaning up from last time. So now let's actually continue. Okay. Env create. With env alloc and call load an ELF binary into it. Let's take a look. Env create. Okay, it's a new, yeah. And sets its env type. Function is only called during kernel init before running the first user mode environment. Okay. But what's env alloc? I feel like I don't. I'm not familiar with it. Is it already written? Wow, they wrote a lot of code for me already. What does this do? Allocates and initializes a new environment. On success, it's stored in some place. Returns a bunch of errors. So you give it a double pointer. So env here, wizard, is what they call env. So env stands for environment, and for some reason, within JOS, which is this, I guess it's not quite visible, within JOS, you can see it right here, they don't call things processes, they call them environments. So, but it's basically a process, and it's a structure that describes a process, basically. And so at a high level, what we're doing is creating the first process on the system. And there was like some reason they don't call it a process, but they just call it an environment. So what does it do? So it does a check, and so there's this env free list thing, which is like a list of environments, or like a array of environments. And if that's null, the free list is null, there's no environment to even allocate. Otherwise, it points at, I need to kind of remember, I need to quickly refresh how this works. But I have my handy visualization. So they're using the same pattern we've used like all over the place, where basically just things are pre-allocated. We have an array with like a fixed amount of maximum processes. They're all laid out in an array, and we have a free list that points at the start. Although I think this gets adjusted. Yeah, so I think, and free list might point to null. It just points to the current head of the free list. And I'm assuming they need to mutate end free list and point it. Yeah, this is where they do that. So yeah, they do so much stuff. So they basically try to get the head of the free list. If it's null, there's nothing available. Otherwise, there is an environment available to use. We call env set of VM, which initializes it. I don't understand any of this generation ID stuff. That is completely foreign to me, but apparently they do it. quickly, what does this thing look like? So what's in an env? Trap frame, linked list pointer, some ID, I guess. Yeah, some kind of unique ID, some parent ID, a type, a status, a runs, and an address space. That's it. So now it's just kind of setting some more stuff. So we somehow, yeah, the whole point of the generation thing is to construct some kind of ID for the environment. The parent ID, what? Oh, you pass in the parent ID, interesting. It gets a user type, it gets a runnable type, runs are 0. Clear out the saved register state. Okay, just clear out the struct. Yeah, basically the idea behind this is that we have our free list. There might be, like, an environment might get freed, but freeing an environment doesn't overwrite the data in the struct. So we need to be careful to not use stale data from the last environment that was running within this like object. And then we set a bunch of things in the trap frame, which I kind of don't really even totally know what it is, what the trap frame even is. I have some vague understanding that it's a place where you can store like register contexts and stuff like this, something like that. And it's related to interrupt handling, I think. DD, there's all this segmentation stuff. So we set some segment register values and also or in some bits for the privilege level, which is 3. You will set env.tf EIP later, and that's the thing that I needed to do in the ELF loader. Now I understand. Let's do that. My code. And it's time somehow for another 20-second break. I'll be right back. Stretch. All right, hope everyone had a good stretch. That's the rule. That's the rule if you watch the stream. You gotta make sure you stand up and stretch. Okay, so now I finally understand what to do. That break was too fast. Yeah, we do not have time to take long breaks here because we only have like 2 hours or 2.5 hours or whatever. So we gotta keep it speedy. Okay, to do something with the program's entry point, we need to set it. So env.tf for the trap frame. Maybe I will just, yeah, I'm just gonna type it out just to get the muscle memory. tf EIP for the instruction pointer, and then I guess I just set it. I just set it to entry. So there's this entry point address field within an ELF, in the ELF header actually. And where's my ELF header? It's in this, it's just this ELF thing, okay. So ELF entry point, I think that is what I need to do. And I'm going to do this last. Only because it is sort of conceptually separate from these other things. Like basically all of this stuff is like allocating memory and mem setting memory. And the stack thing is basically just that, and then this is a little bit different. So I'm not going to put it, I'm going to just kind of put it in a separate part of the code. And I think I'll just delete the comment. Or maybe I'll just add a comment that's set set EIP. I don't know. It's like set the trap frame member EIP to entry point, but really the why, like why are we doing this is make the program, make the binary start execute from entry point. It's kind of more of like the why of why we're doing this, and then you can kind of see the what just from the code. So I'll adjust this comment. Oops. Is set in load icode. And then now I will just commit this. And maybe I will also amend it into the load icode commit. All right. Okay, so we set like a ton of stuff in the trap frame. I don't like really get that, so I'm kind of glad they wrote it for me, but eventually I do want to fully understand that. And then they commit the allocation. What does that mean? It just means make the free list, like basically like kind of like pop the first entry off the free list and make the free list point to the next one. And then save the current end pointer. Save the current end pointer in like the output parameter of this function. Trap frame like a state machine. Let me see if I can pull up my manual actually. Tell manual. The trap frame is like it's like a term in the. It's like a x86 term, and if I was like really good, I might be able to know where to find this. Chapter 6. Exception and interrupt handling. Trap gate. Trap tasks. It's somewhere in here. Yeah, I don't want to search for just the word trap. I want trap frame. But preview is like impossible to use. Trap frame. Stack frame. Yeah, it's somewhere in here. I wasn't able to find it. 64 no stack frame. But yeah, it's like an ISA thing. Yeah. But yeah, I mean, I eventually will need to look up that documentation though. So I kind of do want to actually just find out where it is. It's definitely in this section. External interrupts, source of exceptions. It's like the trap frame is pushed onto the stack. Something. the processor saves the current state of the E flags, CS, and EIP registers on the new stack. I think that is what, like, yeah, we're looking at. I think, so maybe the word trap frame is not used in the manual, but that's what this is. And actually, let's take a look at the code. What is a trap frame? Trap frame is a packed structure, which is like super important because it needs to precisely match, below here, defined by x86 hardware. Below here, only when crossing rings. So we have like a bunch of registers. That's the first part of the struct. And then we have a bunch of other stuff. There's all this like weird padding. Does this roughly match CS, E flags? CS, it's like, yeah, it's like error code, EIP, CS, E flags, error code, EIP, CS, E flags. For some reason there's padding. I guess that, I hope that's like documented. E flags, ESP, stack selector, and more padding. So yeah, it's kind of defined. I don't know why the comment is here. Apparently it's saying this stuff is not defined. But it's like, yeah. Something like this. Yeah, like this will, I think, be like super relevant later. Like it's not, like I will need to understand this later, I think. So it's actually helpful to take a look at it. But back to here. So, and that's it. So it's kind of just like allocating an environment and initializing it, which is called envalc. So it's kind of makes sense. Someone mentioned XV6 and it said it saves user space registers when the CPU changes from user mode to kernel mode. The JOS. Yeah. I believe JOS works the same way because it's just an x86 thing. Like when you context switch from the user to the kernel, you need to save the registers so you can continue execution, because like if you don't save the registers, you actually just lose all their values and you will not be able to keep running the program after you return from the kernel. So you really, yeah, so it's just an x86 thing. So I would imagine it's exactly the same thing for JOS. Okay, good. So now that was it env create? So now what? I allocate a new. So I need to have a struct env pointer. And the first thing I do is like pass that in. And I also need to give it a parent ID. Parent ID 0? I don't know. What is the parent ID? It's an env ID T first off. T. Does it tell me? The new env parent ID is set to 0. Okay. So I'll just oops, 0. So this should be pretty easy. So load. So now do I need to check for errors? Yeah, like thread if what do I do? Do I panic? This thing is void. Also, who calls env create? Maybe no one, or maybe. hey Ethan. Yeah, totally. Let me use my new chatbot command. And I wrote a few resources on my blog, which hopefully could be helpful. I hope the chatbot is working also. I kind of forgot the command. Yeah. Yeah, there's a bunch of books in there. So I think it does. Okay, there's like this macro or something for the end of create. But do I need to understand that? So this thing calls end paste 3. What? Well, anyway, it doesn't do anything with the return value. So I can only assume we panic if ret is what, less than 0, kind of on end of alloc. Okay. Can I do a format string? Yes, I can. How does this work again? Or no, or panic. It's just a Mac. If it parks. I think here. I'm just going to try, I kind of don't remember. Does this compile? But I'm not running far enough to get there, so let me maybe try to run this then? So, yeah, who calls check load icon? That's called in init.c. I see. What's trap init? I haven't gotten there yet, so whatever. I'm just gonna move a bit more quickly. And then load icode, right? Or what are the arguments here? It's like the env, it's like e, and binary. And this thing returns an int now, or did it always return an int? Yeah. 2 less than 0. Okay, it's a new env. Loads the thing into it with load icode and sets its env type. Oh, I see. Okay. Type equals type. Okay. Well, I hope that works. Hey, Nirajan. Thanks for joining. I kind of never know what to do with like the naming of these things. I could also just use I could reuse ret, but I don't love mutation. I could also inline the call into the if statement, but I don't love doing that either. I don't love doing function calls that have massive side effects and stuff inside if statement necessarily, so I will just keep it like this. And I can do const, because it's never used again. Okay. I can't run it, but I can at least try to compile it, I guess. It compiles. Okay, so that wasn't that hard, and let's move on. Env run. Start a given environment running in user mode. Env run. Okay. Context switch from cur env to env e. Note, if this is the first call to env run, cur env is cur env global? It is global. Okay. Oops. Function does not return. Okay, and none of this is implemented yet. Okay. Context switch from cur env to env e. If this is a context switch, a new environment is running. What do you mean if? If this is a context switch, set the current environment, if any, back to env runnable if it is env running. Think about what other states it can be in. Right, okay. Context switch from cur env into this new thing. Cur env is like this global state. Env is the new one. I still don't exactly understand why they're saying if. Kind of, I'm assuming it's always going to be a context switch, but maybe, I guess, like, what if the same environment is passed in that's currently running, I guess? Set the current environment back to runnable. Okay, maybe it would be good to just review the states, or no, env, struct env, come on, env.h. So these are the different states. Free, dying, runnable, running, not runnable. So it's just like scheduler related stuff, I guess, but I actually don't know what they mean, having never worked with this part of the code before, but doesn't matter because it's time for a 20-second break. Be right back. What is it you develop? I'm working on the basically user space processes. And not to be rude, but it would be glad if your mic volume was a little high. Oh, really? Oh, thanks for telling me. I can totally do that if it's helpful. I can bump it up very easily. Let me just try. Check, 1, 2, 3. I don't know. I don't know if that did anything, but thanks for the feedback. So there's all these states. So basically the point is like this environment is not running anymore. It's runnable. What other states it can be in? Okay, whatever. Set current env to the new environment. Set its status to env running. Update its env runs counter. Use lscrf to switch to its address space. Use env pop tf to restore the environment's registers and drop into user mode in the environment. Okay. Can I run the project? Yeah, at some point. Currently I'm not really ready to do that because I haven't implemented all the things I needed. But hopefully I can get there within the next hour. To restore the environment registers and drop into user mode in the environment. Okay. Hint, this function loads the new environment's state from envtf. Go back through the code you wrote and make sure you set the relevant parts of envtf to sensible values. Wow. What is it talking about? What is it talking about? Relevant parts. Is it talking about the EIP thing that I did? I hope. I wonder if there's other things I needed to do. Maybe there is a lot more that I needed to do that it didn't tell me to do. Oh man, Viper, do not hug your pop's shotgun. DSA, what is DSA also? DSA in C++. Okay, I'm going to let's read this a little bit. So I read all this part. This is just talking about how it has these binaries, data structures, and algo. Oh, I see, okay. This part is just talking about how it takes the binaries and embeds them into the kernel for easy access since I don't have a file system yet. So that's not that interesting. Below is a call graph of the code start, init, meminit, envinit, trap init, still incomplete. Okay, mcreate, envrun, and pop tf. Once you are done, you should compile it and run it. If it goes well, you should enter user space and execute the hello binary until it makes a system call with the int instruction. At that point, there will be trouble since JAWS is not set to the hardware to allow transition into the kernel. When CPU discovers it can't do that, it will generate a GP exception. Can't do that, do a double fault. Can't do that, and then do a triple fault and reboot. Oh, well, this is important for legacy applications. See this blog post for why it's a pain for kernel development. Okay. So use the patched QEMU to see a register dump. Okay, I don't have the patched QEMU, so I guess I can't do that. We'll address this problem shortly, but for now we can use the debugger to check that we're entering user mode. Use this and set a breakpoint there, which should be the last function before actually entering user mode. Single step through this function using step I. It enters user mode after the I ret. Interesting. You should then see the first instruction in the user environment's executable, which is the comp-ol at the start label, a libentry.s. Let me just send you the link, Viper. It's this MIT class. Yeah, but it is pretty cool. Patched QEMU. Yeah. So I should totally be able to do this part. So, all right, let me just try to write this code. What's it saying? So I need to set the current. Maybe I'll just do it stuff inline. Current environment, current status. Wait, I kind of forgot it. H. It is a status, right? Oh, it's just env status is just an unsigned int. Okay. Env status equals env runnable if it is an env running. Okay. So if equals env running, set it to runnable to do think about other states it can be in. Okay. Set cur_env to the new environment. So I guess I can just safely do this because it's not like we lose it. It's just a pointer into the free list anyway. So I think we can just do that. Set its status to env running. Equals env running. Update the env runs counter. Oh, by the way, is my volume better? Nirajan or whoever, I don't know. Or in general, just curious. If it's too quiet, yeah, totally happy for the feedback. If it's too soft or something, or if the music is too loud or whatever. What is the env runs? Number of times environment has run. So I guess env runs ++. And that is a uint32t. So to be a good C programmer, I would probably need to stop and think about overflow. To be honest, I don't. Yeah, I mean, this probably can overflow. I mean, 32 bits is kind of a big number, but like, it's not that big. Like, you can definitely overflow a 32-bit integer, especially if it is incremented every single time a context switch happens, which like can definitely be a lot. So I think maybe I'll just do should env runs be 64-bit. Yeah, Nirajan, I think even size T is not big enough because I believe size T is just a 32-bit also. And so I would really need to go for the int 64t, or the uint 64t is what I would really need to reach for. Yeah, size T is 64 bits if you're on a 64-bit system. But I believe, but size T just represents the size, and I'm on a 32-bit system. So be 64-bit. Use else here, 3 to switch to its address space. All right, let's go. Cur_env, or what is it, pagedir? Getter. I slightly forget how to do this, but I believe that's right. everywhere we call load co3, we use the p adder, with the exception of like that poisoning thing. But yeah, so we can work p adder. And step 2, use env pop tf. So what does this take? A trap frame? So cur env trap tf to restore the environment's registers and drop into user mode in the environment. Does this compile? No. Oh, is it a pointer? Yeah. Okay. Good. So that wasn't too hard. Hint, this function loads. So now what do I do? Panic. Right, yeah, if I were to run it, I forget where my panics are at. Check with iCode. So I'm actually going to remove these unit tests because they actually kind of modify the system state of the actual kernel. At least region alloc does, I think. I've only implemented this far, good. And then I'm just going to do panic 22. Oh, okay. Wow, and it's already triple faulting. Yep, I'm using tmux. It's already triple faulting. Why is it triple faulting? What about here? Okay, no triple fault. What about here? And a triple fault. What? Wait, are you using background sound is attractive? Oh yeah, the music. Yeah, lo-fi beats. Wait, what? What about here? I feel like I'm just spending my whole life debugging triple faults. Even there, what? What the heck? I'm so confused. How? What is happening? Okay, well, that is not that fun. But this is very odd. So yeah, I gotta be honest, I'm not that excited at the prospect of debugging another triple fault or whatever is going on. But it seems like reading the status out of the current environment triggers a fault. No. Or wait, no, maybe I got that just wrong. Like, it's like a null pointer dereference, I think. Because, wait. Is cur_env a null pointer? I really hope it's a null pointer. Please. Yeah, okay. Whew. Cur_env and, okay. Whew. It was just a null pointer dereference. Man, these triple faults are giving me nightmares. It's so traumatizing. Oh, so wait, but wait a sec, I don't know. All right, no, I totally did this wrong. No, I am so bad at writing this. So if not cur_env, yeah, wait. So if there, no, what am I doing? If there is a cur_env, wait, what? Wait, I could have sworn, wait, whoa. What is going on? What is going on? This triple faults. Assert cur_env. So what is... okay, panic, 1, 2, 3. I think I'm pretty sure it's just like something super stupid. So okay, it's probably triple faulting because it actually executed all the way through. Panic, stop. Okay, wait a sec. Come on, stop. Okay, we hit the stop. Okay, man, this is crazy. Yo, what's up, Pingu XOR? I was just stressing out because, man, this thing is so, like, basically at the stage my kernel is in, any kind of error just triggers like a bunch of reboots. And it's very difficult to discern the different errors. And so what was happening is I accidentally had a null pointer dereference over here, which was causing the reboots. Then I fixed it, but then forgot to stop execution before here because this function is intentionally currently right now going to cause reboots because I haven't basically finished making that part work. So it's fully expected for reboots to happen if this ever runs. And so I just got super confused, but basically, yeah. Basically in this case, cur_env is a null pointer. And so I can't just blindly be accessing its fields without a check. So now I have my check and it all works. So that looks good. And then I think this is totally expected. I believe, because purely based on what this thing says. So this thing says, run it. If all goes well, it should enter user space and make an int instruction. And then everything will like really crash, whatever, but it should get there. And I guess I should really confirm this, and it kind of talks about how to do this. So maybe let's do that. So go into our handy GDB Okay. So what's it saying? It's saying pop tf run. Okay, we're in pop tf. Wait, what does pop tf even do? I don't actually know. Never read that so far. Oh, it's pretty short. So this takes a trap frame, restores the register values in the trap frame with the iret instruction, exits the kernel and starts executing some environment's code. This does not return. Wow. Wow. I do not understand this code. So we'd have a trap frame argument. It's a pointer to a trap frame. Trap frame is that special structure with all the context or whatever. And we move the trap frame into ESP? I don't actually know inline assembly well enough to really understand this super well. But we basically set the stack. Pop AL. What is that instruction? I actually don't know. Instruction. Pop all. Oh. What is that? Am I reading that weirdly? But it's one of these. Oh, it's one of those like. Let's read this. Let's read this oracle.com website. Pop AL. The 8 16-bit general registers are popped. However, the SP value is not loaded into SP. Is pop A restores. I'm going to take a screenshot of this, save it in the stash of documentation. So yeah, basically x86 has some instructions for very conveniently saving and restoring register state. And the registers are, in this case, being restored, like popped off of the stack into the registers. And like the, yeah. Say gay, see? Okay. So something along the lines of make the stack pointer, maybe I can visualize it. It's always helpful to visualize things. So we have like some memory. We have the trap frame, which is like in memory. And we're going to make the stack pointer point at the start of the trap frame. And the trap frame has what? It starts off with all of the push registers. It's what, like 8? Useless. Interesting. If I push A. So it starts off with general purpose registers. Oh no, red. That's pretty intense. Then like other registers. And so this, basically the trap frame exists in memory. It looks kind of like this. We point ESP at it, and then we're going to do some assembly. To pop AL. So presumably that's like taking all these registers and popping them into the actual CPU state, which I'm going to represent over here, CPU state. So basically, yeah, pops those into the CPU actually. This is not a pointer, it's just kind of like a transfer of data. Pop LES, pop LDS, interesting. So these are the next things in the frame. Oops. So pop AL. And I guess it like actually pops the stack, so it adjusts the stack pointer. I didn't quite read that super carefully, but it's time for a 20-second break. Be right back. So yeah, this is the 8 32-bit registers are popped by pop AD. Okay, whatever. However, the ESP is not loaded into ESP, it is discarded. Okay, the ESP value within the trap frame is not loaded. I think that's what it means. And I think that's what it means. I think that's what the code means when it calls this useless. Like OESP. I wonder what that means. Okay, whatever. So it's just like popping stuff out of the trap frame, basically. Including some segment registers. Then it adds 8 to skip a few things. And then it does an IRET. So it skips the trap number. So DS was the last thing. So then it adds 8 to skip these two things, which sets it here. So now it's pointing at an EIP, a CS, a padding 3. And here's the part where I'm going to try to go back here and probably also screenshot this. I mean, there's actually just probably straight up documentation on how the IRET works. Reference, what is the reference? Oh, just the flag usage, interrupt tasks. Descriptors. Where was this? Maybe I should just look at the iret instruction. This is going to be so complicated. Returns control from exception or interrupt handler to a program or procedure. That's the task. Oh. Mnemonics, blah, 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 blah. In protected mode, the action of the iret instruction. Wow. We want like this. We want an inter-privilege level return, I guess. As with a real address mode return, the iret instruction pops the return instruction pointer, return code segment selector, and eflags image from the stack to the EIP, CS, and eflags registers, and resumes execution of the interrupted program. That is like the key information. That's the key information. Okay. And that's what we see in the code. So in the code, we see what they adjust the stack, so it points basically right at the EIP, and it says instruction pointer, return code, the code segment selector, eflags. And then there's like even some more stuff, some ESP and a stack selector. This comment says it's used only when crossing rings from user to kernel, which is what we are doing because we're crossing from kernel to user right now. But, or maybe, yeah, maybe even it's documented or something like that. Stack selector? Code segment selector, stack segment selector. How do I? This is not. It's not like talked about. But the SS is the stack segment selector, I think. Okay, so now we're getting into like the real nitty-gritty of Hex86, which I need to learn more about. But anyway, that is roughly, I guess, what this does. What does the G do? Inline SMGC. Extended. How to. I'm just going to ask ChatGPT real quick. What does G do in HC in line assembly? General operand. Tells the compiler that operand can be stored in a general purpose register, memory. Okay, super flexible. Basically just like, you can just use it kind of anywhere. Interesting. Yeah, I don't actually have amazing understanding of what this thing is. I just have some like understanding that when you want to take C variables, but then kind of reference them within the assembly, you pass the C variables kind of into the inline assembly, but then you need to give it this like string label, which describes, I guess, how it appears, like what the final form will be. And you can say it really needs to be a register, it needs to be in memory, it needs to be an immediate maybe, but maybe with the G it's like I don't care, it doesn't matter. So thanks ChatGPT. I think that's enough understanding to go ahead with this debugging. And I guess I'm just going to step instruction. So we're in the prologue. So now we're pop A, pop ES, pop DS, add ESP. So now we are right here. The iret is coming up. Iret. And what is going to happen? All right, moment of truth. I think that worked because now, so it didn't crash first off. And it appears like we're now executing at the entry point of the user space program at this hex 8, like whatever 8020 thing, which is what we see here in the entry point address. So this is kind of cool. So now I want to go into the obj and I don't know, user, was it hello? Oh, oops. Just tried to run that. All right. So here's the start. And this is where we are at right now, basically. I'll make this a little bit bigger. Comp, JNE, what? So we're push, like all this. Call, lib, main, jump. What is it? What does the course say? Now use break to break point at the int3 in sys c puts. Okay. Puts. Which is right here. So I got the address of the interrupt and I can use it and I can continue and we hit it even. Or, oh. So now I need to disassemble at the PC. And yeah, we really see it. We really see it, guys. We see that we are about to execute an interrupt hex 30, which is going to completely crash everything because we don't have interrupts set up yet. But that, I'm going to call that a great success, because that means I finally completed exercise 2. So yeah, I'm going to call that a good success. And I kind of want to keep going. Yeah, I'll keep going for a little bit longer. But just get some water. That's pretty cool though. Maybe I'll do some Git activities while I'm here. So yeah. Implement and create. Don't need any of this. To do, think about other states it can be in. What other states can it be in? Maybe I will stop to think about that for 1 second. So free, dying, runnable, not runnable. So if it was running, it definitely can be runnable. But what if it was these other things? What does env free mean even? Is this used anywhere? Wow, okay. Env ID to env. Bad env. So it's just like an available environment, which is 0. Okay. I was wondering why, like I would expect there to be some code that is setting the status of something to env free, like when it's in the free list. But I think what happens is we just mem set them to 0 anyway, and this thing happens to be the first one, which is 0. And so by like default, they get implicitly initialized to free. Cool. Dying, runnable, not runnable. So what if it was not runnable? Then yeah, but currently all we do, we only set something to runnable if it was previously running, which I think is pretty conservative. If it was already just kind of runnable, then nothing happens, it just stays runnable. Not runnable, then we don't, if it was not runnable, we don't try to make it runnable now, we just don't do nothing. So I think this is like decent. So I guess I will just stage all this, and I won't. Whatever. Yeah. And run. And I will get rid of this. Remove panic. And I guess I need to remove this too. Or wait, no, I think I messed up. Check load iCode. I think I actually. Wait a sec. Oh well. I kind of forgot where that even was. And is it here? Quit. This. Okay. Looks right. I actually kind of wonder. I'll go back to GDB. Is it possible for me to just break on the X30? Am I just puts? No. Right, can I just directly break on this? Continue? Yeah, totally, just, yeah. So, yep, so that's still working, so I'm good. I am just kind of curious. It should still totally work if I have these things, but I'm just going to ignore that for now. Alihan, why are you changing themes every episode? Not every episode. This is actually the first episode I've changed the theme. For pretty much every episode prior to that, I've been using the white theme consistently. Okay, let's I guess time to do some reading. So, as a bit of a sneak peek for next week, handling interrupts and exceptions. So at this point, it's a dead end. You can't get back to kernel mode from user mode. Now I need to implement basic exception and system call handling so that you can recover control. The first thing you should do is read the x86 manual for like 5 years or whatever. Familiarize yourself with x86 interrupt and exception mechanism. Read the manual. Okay. Blah, blah, blah. Basics of control transfer. Exceptions and interrupts are both protected control transfers. Okay, this is just kind of an overview of how x86 works. You can have interrupts from like devices, for example, or you can have exceptions, which are kind of like internally generated. There's a very specific mechanism for how you enter the kernel from user space. And there are some specific mechanisms that like implement that. So you have the IDT interrupt descriptor table. And so with the interrupt descriptor table, you can register a bunch of entry points using interrupted number, which they call a vector. 20-second break. All right, be right back. So you have a bunch of possible entry points you can set up, 256 of them. Interrupts vector. Yeah. Creation request to the kernel, generate interrupts with different vectors. CPU uses the vector as an index. Okay, got its entry. So yeah, in the IDT, there's like these entries. Yeah, I totally don't know the details of that super well, but you can get some stuff out of them. There's like an EIP that points into a kernel, points to kernel code, and a code segment register, which includes some privilege bits. Except they're pretty much all handled at privilege level 0. Okay, and then you have the task state segment, yeah. Processor needs a place to save the old processor state before the interrupt arrived, so you can resume later. But the save area must be in turn protected. Otherwise, buggy code could compromise the kernel. So it causes a privilege level change when you do the interrupter trap. And switches the stack. A structure called the task state segment specifies the segment selector and where the stack lives. It pushes a ton of stuff onto the stack in error code. And it loads the CS and EIP from the interrupt descriptor and sets the ESP and SS to refer to the new stack. Okay. It's large, whatever, just only uses it to define the kernel stack. The processor should switch to when it transfers from user to kernel mode. Processor uses the ESP0 and SS0 fields of the TSS to define the kernel stack when entering kernel mode. And yeah, lots of things to learn. This is like the really juicy stuff, I feel like. This is the stuff, yeah, it's like the really kernel dev type of stuff here. Interrupts, exceptions, yeah. But that'll be it for this week because we're out of time. So yeah, thanks a lot for tuning in. I'm just gonna plug myself. Feel free to join the Discord if you want. I'll post a link. Like, comment, and subscribe. And yeah, thanks a lot. And I'll see you next week. All right, bye.